Hello everyone, my name is Sudipta. My master's supervisor, Professor Dr. Hansen, and I are working to determine the effects on surface water quality due to Corn-Soy rotational cultivation occurring in northeastern Kansas. With growing demand for biofuel production, the other regions of Corn Belt are becoming more and more saturated with corn grain cultivation and ethanol biorefineries, and it is also expanding to nearby Kansas. For the last 15 years, Kansas has also experienced an increase in land use conversion from grassland to corn soy rotational cultivation, but the impact of this corn production increase on surface water bodies is still unknown. So in our project, based on determining and modeling the surface water quality at watershed scale, we are exploring how correlated the water quality parameters with grass to cropland conversion and what is the extent of sustainable biofuel crop production in this region. So for our study, we have selected Delaware River watershed, which experienced cornland intensification in recent decades. Lake Perry, downstream of this watershed, is a regionally important reservoir with sedimentation and eutrophication problems. So we have used the crop data layers available from this Department of Agriculture to determine the land use change that occurred in the watershed from 2006 to 2020. So from figure 1, we can see that there occurred a steady increase in corn soy production and 20% reduction in grassland area. It is clear from figure 2 and 3 that the 15% increase in corn soy cultivation area is mostly attributed to the grassland to crop conversion at the northern edge of the watershed, which is also most susceptible for water quality degradation. So to catch the associated effect on water quality, 30 sites were selected based on land use change intensity and accessibility of the location. With the water samples that we collected for the summer sampling event in 2021, different water quality indicators like total nitrate, soluble reactive phosphorus, total suspended solids, percent organic matter, dissolved organic carbon, total and environmentally relevant anion concentrations are determined. So from figure 4 and 5, we showed the result of the total nitrate and soluble reactive phosphorus concentration, which are greater in the upland portion of the watershed, where the intensity of corn soy production is highest. The percent organic matter for suspended solid is also highest in the agricultural dominated northern edge of the watershed, as well as in the sites adjacent to the Perry Lake Reservoir. Total suspended solid concentration is higher in the middle region of the watershed, where all the streamlines from the agricultural land converge. So we have seen that the northern part of the watershed, that is the Nemaha and Brown County, which are most agriculturally intensive and high corn soy production in this area, is proportionally related to the high nitrate and SRP concentration. So we have also found that the total suspended solid concentration and percent organic matter presence at each catchment are inversely correlated. The catchment areas with more total suspended solid concentration are showing lower percentage of OM organic matter values actually. So the effect of biofuel expansion and intensification is evident in the result that we have found from the water quality parameters, but it doesn't necessarily answer all our questions. Up to this point, we are certain about more of the grassland have converted to cornlands, and there is an effect of agricultural production on water quality indicators in catchment and also in sub-watershed scales. So in the next step, the seasonal variation in water quality will be assessed with additional sampling events, and we will try to use the field data and publicly available monitoring data to develop a watershed water quality model to simulate the effect of biofuel expansion and intensity on water quality and potentially identify locations of land use conversion that do not severely affect the water quality. So if larger areas of land use conversion are possible without adversely affecting the watershed environmentally, we can reach to a conclusion that Kansas can be a suitable place for biofuel generation. Thank you.